I'll be chairing this session with Professor Michael Reiss from the Institute of Education at UCL. I'm a professor of science education, and so is Michael, but he's a lot more than that. And because I don't have the memory for all the things that he has done in his life and continues to do in different capacities, I had to have a little memory, which usually I don't need, and it has nothing to do with COVID and memory loss. It has to do with Michael and the immense amount of work that he does. Apart from being a science educator, he's a bioethicist. He's interested in bioethics. He is the president of AAC, which is a prominent science education association, and he is an ordained priest. I mean, I don't know how many people can combine those sorts of qualities in one person, but here he is. He is, I mean, just to give you a sense of the sort of things that Michael is interested in, and he's so prolific and is a true scholar in my view. Some of the titles of his books that he's written: Cognitive and Metacognitive Problem-Solving Strategies, Learning Science Outside of the Classroom, Values in Sex Education, anyhow, but it's just a really long paragraph, and it's just really, I underlined a couple, but there's a lot more. So it's science education, bioethics, sex education, values, and it all hangs together in his scholarship, which may sound disparate at times, but actually quite holistic in terms of his approach to education. And we're really delighted that he's come here today to talk to us about truth, science education, and vaccines. And what an opportune moment for us, for him to accept this invitation to talk to us on a timely issue. So really delighted that you could make it, Michael. So over to you. Just to give you a sense of the logistics, we'll take about an hour of presentation and then half an hour until 6:30 for discussion, question answer, and we will the online participants as well will join us at that time, hopefully. And afterwards we'll have drinks and nibbles in the common room at the back over there. So hopefully you'll be able to stay on and have further discussions with Michael at that time. So over to you, Michael.
Right, well, first of all, thank you for that wonderfully generous introduction. I'm just sorry no of my family here to have heard it, but I do appreciate it, Sibel, enormously. I look forward to listening to the recording again, so thank you very much. In terms of the timing, I'm not going to get you to do any activities in groups or anything like this. This is pretty conventional me, so it's going to be shorter than an hour, because otherwise you'll be comatose. So we'll have me, then there'll be questions, answers, comments, both online and in the room. So as Sibel says, it might be 1:30, it might be a little bit earlier, that those of us in the room can go for nibbles and drinks, but it won't be later. Okay. Can I say it is really nice to be here, as I thought would be the case. There are a number of you I know extremely well, which is lovely. There are some others whom I've heard of but haven't previously met, and there are some of you I don't know at all. And that's probably true of people online. So it's very good to be here with you. I want to start more broadly with issues facing school science education nowadays. And there are a lot. They vary from country to country, of course, but they do include the fact that it is demanding to teach school science. Now, it's demanding teaching any subject at any age range, but I think teaching for the 5 to 16, 5 to 19 age range is particularly demanding. And for school science, there are a number of reasons why you have to learn more things than possibly in some other subjects. In many countries, including the nations in the UK, there are real problems about having enough specialist teachers of science. Then there are issues to do with the resources for teaching science, whether it's for practical work, whether it's textbooks and things like that. A common feature in an increasing number of countries and for increasing number of ages of students is the examination pressures. These are not worse in England than in many other countries. There are some people here who are real international experts on examinations and assessment more generally. But one of the first academic books I wrote in science education, and I ought to say the three great books that Sibel mentioned were all co-authored. But one book I wrote on my own, which came out in 2000, talked a lot about the pressures of examinations on students in school science. And it's only actually, it's a bit complicated, but roughly speaking, it's got worse since then in terms of the effects of those on pedagogy in teaching science in England. Now, one could carry on with this litany of how difficult it is to teach school science or how it's all got worse, etc. But there are some enormous positives, some things that school science teachers should be very grateful for compared to some other subjects. For a start, trust in scientists is, in most countries in the world, not all, but it's very, very high compared to many other professions. So you probably know that in the countries, the nations in the UK, if you ask people for what are the most, or how much do you trust different professions? Professions like doctors, scientists, nurses, teachers score very, very highly. Then there's a lot of people in the middle, including clergy. We used to do better, but we've got worse over the years for obvious reasons. But we are a lot better than advertising executives and estate agents, and rather sadly, journalists, which I always feel sorry for because vast amount of journalists are wonderful and it's a pretty dangerous occupation in many countries. This, as you may know, the trust in scientists does quite interestingly vary from country to country. So it's very high in some countries, such as England, Scotland, Wales, Northern Ireland. Other countries which have had more of a history of scientists almost always working under government state control, then the general trust in science tends to be much lower. And that will connect with issues to do with vaccination when I get onto that a bit later. We do have a lot of enthusiasm for science among many students, at least at the start of their school careers. As some of you will know in detail, a lot of work has been done on attitudes to school science, often sadly not done in parallel with attitudes to other subjects. So science educators generally bemoan the fact that students get less keen in their responses to questionnaires about their attitudes to science or school science, but then to be blunt, they get less keen on almost anything filling in questionnaires, do people as they get into their teenage years. And it's quite difficult to know whether science is more of a problem than other subjects or not. But at the start in primary schools and at the start of secondary schools, we tend to have great enthusiasm for science among many students. And of course, people, the general populace, this is true in countries around the world, whether so-called developed countries or so-called poorer countries, very high value is placed on advances in agriculture, medicine, IT, all topics closely associated with science. Now, the next bit is absolutely just sort of teaching mode, 3 visions for science education. So some of you will know these, but others of you, I think it rather likely, will have never come across them before. The first 2 are due to a man called Douglas Roberts. And vision 1, this is a vision for science education, and all 3, in a sense, are different understandings of scientific literacy, what it is to be literate, knowledgeable about science. Vision 1 starts from science, and the aim is to build up curricula, this is a quote, from its rich, it's referring back to science, from its rich and well-established array of techniques and methods, habits of mind, and well-tested explanations for the events and objects of the natural world. As with all these definitions, one could talk forever. So I can't resist saying in passing that events and objects for those of you who are interested in philosophy of science, as a particular way of understanding the universe. Many other people would start much more from processes and things like that. But there we are. But the rest of it, basically, it starts with science. It's probably what most of us had at school as the way in which we were taught science. Okay, so someone like me absolutely loved it at school. Vision number 2, oops, have I pressed that too quickly? No, that's right. Vision number 2 developed later and is actually closer to how many people now use the term scientific literacy, even though you can argue that all three of these are different understandings of science literacy. And roughly speaking, the idea is that Vision 1, it increasingly became thought, was fine for those students who, after compulsory schooling, carried on studying science, people like me. But the worry was an awful lot of the Vision 1 approach didn't really engage all learners and wasn't always especially relevant to them. So an enthusiasm grew up. The slogan Science for All, which has been around for quite a long time in a number of countries, sometimes called things like citizen science, but more of an emphasis on socio-scientific issues in general. The hope being that if you'd been taught this well and got to grips with it, for the rest of your life, you'd be able to draw on what you'd learned in school as different socio-scientific complicated issues came up. So to take vaccination, the thinking would be that maybe all the questions going around about, should we always vaccinate our children? Is it safe and things like that? You wouldn't have been told all the answers to that from your schooling 10, 20, 30 years ago, but you'd have been given a way of thinking about science and enough knowledge that you would be able to make well-informed opinions. As some people know, in England, the slight problem is that vision got associated with we can have a slightly less academic sort of science for those students than Vision 1. So although at one point the national curriculum got, particularly GCSE at Key Stage 4 for 14 to 16-year-olds, it got restructured to allow these different pathways very quickly, as nearly always happens in education systems when you have alternatives. A hierarchy is perceived, and Vision 1 got seen as for the more academic students, and Vision 2 for the less academic students. And Vision 2 now has a much smaller role in school science in England than it did only 15 years ago. Vision 3 is much more recent. It's much more of a minority interest. It's much stronger amongst science education academics like me than it is among large numbers of school science teachers. So it'll be interesting to see as the years go on, whether that remains the case or whether it grows and starts to permeate school science teaching more. But it's a vision that emphasizes critical scientific literacy more than certainly Vision 1 does, and I think most aspects of Vision 2 do. So it would encourage students far more to learn to get into the habit of asking why and who benefits and questions like that. And then also you'd hope they'd have the skills. Now, I can talk about that with almost any science topic, but I'm going to be concentrating on vaccines for the rest of today. But just to give an example at the top of my head, if one thinks of something like mining, as in literally mining for gold or something like that, if mentioned briefly in school science lessons, it might only be about the context of whether a metal is reactive or not. So gold is notoriously unreactive. So roughly speaking, you get it in a rather pure state. You just have to use mercury in the process for extracting from the way it's found naturally. And that might get just mentioned en passant about some property of mercury or something like that. A humanized version of science education with more of an emphasis on Vision 3 would be far more interested, not only in that, but in, so what's it like to work in a gold mine? And there are two sorts of gold mines. There are gold mines run by huge conglomerates, and they're pretty awful to work in. And there are gold mines run by families. historically for long periods of time, and they're pretty horrible to work in as well. And then you can look at different sorts of minings. And as you may or may not know, I'm spending too much time on gold, Cliff. As you may or may not know, there's a radical movement now arguing we should stop all gold mining, because gold is already one of the most recycled substances on the planet, because it's very easy to, it doesn't react with things and is expensive, and also easy to see, and also even more probably useful. People associate it, with great rarity, even though it's cheaper than a lot of other metals. But there's a move towards arguing we could get rid of all gold mining, because there's enough around for, certainly for jewelry uses, industry uses, medical uses. Right, so 3 different understandings. And I just want to mention the phrase "for all," which came up in the scientific literacy vision number 2, and seems difficult to deny. But school science education, I think in all countries, is still only beginning to get to grips with it. So the area where probably most good work has been done is about gender. Because if one takes a subject like school physics, it's widely acknowledged, and some of you know this better than I do, that many countries, interestingly not all, but many countries have not succeeded in having as many people who identify as being female choosing to go on to study physics once it's no longer compulsory, as have people who identify as male. So in England, for example, roughly speaking, 21, 22% of students who do A-level physics are female. Obviously, the rest, because the number who don't at the moment identify as male or female is very small, so about 77% identify as male. That's actually a bit better than 5 years ago. Tremendous work by the Institute of Physics means it is beginning to change. But chemistry has managed to change much more successfully in the last 30, 40 years. So there's a huge literature about that. There's a growing literature about the way in which socioeconomic factors are important in access to school science. So I just mentioned only one name here, Louise Archer, because she's so well known for her research. She's a sociologist who now works on science education and came up with the term science capital. For those of you who know much sociology, capital is a term particularly associated with the sociologist Bourdieu, who sees, well, I won't give a complete lecture about Bourdieu, but capital is something you have, rather like money. It's capital in that classic Marxist sense of the term. You carry it with you, you can use it, but of course you have to acquire it. So most people acquire it initially from their families, and schools that don't take account of disparities in the amount of science capital that children arrive at the schooling with are likely very quickly to widen the inequalities, because they just start thinking, and this is human nature, well, she's not that good at science or whatever. In exactly the same way as they might think, well, he's not that good at English or whatever. Whereas, of course, the job of a teacher ought to be to try and reduce those initial differences. Not a great deal of wonderful work yet done in school science education around the world and how it connects with ethnicity. There's a lot of sort of data on people from different ethnic backgrounds, how well they do or how likely are they to carry on with science, but it hasn't yet really well begun to change into, well, what pedagogies, if any, should we be using for people from different ethnicities? Or are our curricula appropriate for all ethnicities of students? So questions like when one cheerfully teaches, let's say about names of plants and animals, which just thought of that now. So as many of you will know, the Linnaean system of taxonomy is just presented in school as the best way to name things. So as you will know, it's a by nomenclature way. So with two names, genus and specific epithet. So we are all members of the species Homo sapiens. The common oak tree in this country is either Quercus rubra or Quercus petrea. But it's very interesting. It just gets presented as the best way of doing anything. Now, I quite like talking Latin, so I'm okay with this. And I'm an academic biologist by background, so I'm quite keen on the Linnaean system. I'm a fellow of the Linnaean Society, can talk about Linnaeus for far too long. But it sort of denigrates any other way of understanding naming of animals and plants. And that's just a very, very simple, not particularly contentious example. So gradually people are trying to think about what might be better ways of teaching science that is more inclusive, not so colonial, for example. Religion, which again I could lecture about for far too long, it's relevant to vaccines, as we'll see later, but tends to come up in particular cause célèbres, like teaching of origin of the universe or evolution, natural selection. But there has been quite a lot of good work done on this. And it does connect with vaccines, because my own argument would be, you don't want students being turned off biology, let's just stick with evolution, because they think it's contrary to what they've been taught in their homes or their mosques or their church or synagogues about religion. Because if you get into a battle between science and religion with children, science is usually going to lose, to be honest, because most children are more likely to be affected by the culture in which they live most of their lives than about your 3 hours of science teaching a week or something like that. So you don't want to get into those conflict situations as a teacher. Even less work done about science and how it might be taught with whether it's neurodiverse students or students with physical disabilities. They're literally in this country at the moment, well, I know Jane Essex up in Strathclyde, but there's almost nobody else working on disabilities and science education, which doesn't reflect, I think, especially well on us as a community. Okay, vaccine education. It has become increasingly important over the last 20 years or so. Well, I think actually it's a bit of, I think I'm being a bit hopeful there. It's become a lot more important since about January 2020, being honest. Before that, not really much. Now, here is probably the most important bullet point in what I'm saying today. My experience, this is not some wonderful, careful empirical analysis, I admit, but my experience is that immunization, the posh word, roughly speaking, for vaccination, is generally presented in schools, which is where most of my argument is today, but also in wider society in most sections of the media, most, literally over 50%, as an unqualified good. The follow-up from that, so there are two really important bullet points, is that those who reject immunization, either for themselves or for their children, if they've got children, those who reject immunization are typically seen, as are those who reject the theory of evolution or who reject human-caused climate change, as ignorant of science. In the case of vaccines, they're sometimes seen as being selfish as well, sort of herd immunity argument we may get onto. Now, in terms of teaching people in schools, it's not a very good position to start with as a teacher by giving the impression you think people are either stupid or selfish or have parents who are stupid or selfish. For some strange reason, that doesn't seem to engage and motivate most people. So it's not a very good position, but it is the position, the default position of immunization, vaccine education, certainly in textbooks when you look at them. To repeat, it's just presented as an unqualified good. Right. A little bit of history now. By the way, I am personally quite keen on vaccinations. I've got them in my pocket. I'm happy to show them later, my 4 COVID vaccination certificates and things like that. Not a good idea, smallpox. This is the short version of this slide. Actually, this is not, sadly, being read more, this is not quite as critical. You know, I found this wonderful argument that smallpox ended the Roman Empire. Possibly, it might have been measles, actually, or something else. But anyway, killed a lot of people. This one is really interesting. This one, the historical data is good on and is deeply depressing. So when we got people, particularly from Spain and Portugal, colonizing South America, they introduced smallpox. It was introduced in 2 ways, intentionally and unintentionally. Even if it hadn't been introduced intentionally, the effects would have been the same. It just sounds more horrific, the throwing over of people who died of smallpox, catapulting them into areas held by indigenous peoples and so on. But as you may or may not know, I'm afraid that the academics who work in this area think about 9% of indigenous peoples in South America died within a century of the invasion by Europeans. In fact, because of that, farming decreased so much that there was less carbon dioxide in the atmosphere. And 1610, just me, am I hearing background noises or other people?
Not muted on Zoom.
Oh, it may be, okay, so just to say, if we're on Zoom, if possible, I think we ought to probably have our microphones turned off. Because at the moment, Hannah or somebody else, they're getting much more interested. Speak to me, Hannah. They're getting much more, thank you. They're getting much more interested on the sort of moaning sounds that are coming from somewhere than what I'm saying. So 1610, quite seriously, was the coldest that it's been in historical times, the last couple of thousand years, that sort of period, little ice age in Europe, that sort of thing. And it was because of the decrease in agriculture in the Americas caused by smallpox. And therefore, I won't go into a whole lecture about the carbon cycle, but that's the short version. Now, so we move on to even better historical data. 18th century Europe, about 400,000 people died annually, which is a lot. And 1/3 of survivors went blind. Mortality rate varied from about 20% if you were pretty healthy to 80% or more if you weren't, if you were malnourished or very young, for example. Now, this is the bit I only really, well, actually only quite a while ago, but it's really interesting anyway. So as early as 430 before the Common Era, so 2,500 years ago, people had learned that you weren't very likely to get smallpox twice. So if you had survived it, you were the people who were then called to help nurse those who had got the disease. So it's the beginning of an understanding of only getting something once of natural immunity. And then there's this wonderful technique called variolation, which was practiced in a number of countries in the world, a number of African countries, in India and in China. The essence is you wait till somebody who has had smallpox has recovered. You wait weeks, that was known. Don't do it too quickly. The longer you wait, the more effective it'll be. Well, not quite effective. The longer you wait, the less likely it is it'll kill somebody. And you take, preferably from somebody who didn't have too bad an attack of smallpox, you take the dried up, by now, pustules, spots from the person, grind them up. In Egypt, you blew them up the nose, I think it's the left nostril of girls and the right nostril of boys, which is not something we think nowadays is important, but they developed a mild form of smallpox. And the death rate was only about 2%, which is a lot, but for those of you who are not strong at mathematics, it's a lot less than the 20% I mentioned earlier, which was typical death rate if you were fairly healthy. So the practice of variolation got used quite widely. And some of you may know this story because this does get into some school science textbooks. In March 1718, Lady Mary Wortley Montagu ordered the British Embassy surgeon in Istanbul, Charles Maitland, to inoculate her 5-year-old son using this process. The reason being she'd had smallpox and survived it, and was terrified of her children dying from it. And in Turkey, which is the relevant bit about Istanbul, her husband had gone off there for a job, she found, which she'd never heard of before, variolation was used quite widely. So success, came back to England. That's a picture of her by somebody, an artist, you wouldn't be surprised at the time, who has not identified her pock-marked face, which she did have, because there's quite a lot of gender-specific commentary about the effects of smallpox on what people look like. And she was a renowned beauty before she got smallpox. And here she is holding her son. There were then both for variolation and later, well, stay with the variolation, there were trials on prisoners and orphans, who were the sort of, standard equivalent of beagles of the day. So they were used to do all sorts of trials, actually. And as I've already said, variolation worked and only killed about 2% of people. Jenner. Now, I could give a complete lecture about Jenner. You'll know the story, 8-year-old Thomas Phelps. Jenner's, well, the observation was well known, and it's even in fables and songs of the time, that milk girls look beautiful. What it means, of course, is basically a high proportion of them got cowpox, temporary disease, almost total recovery from cowpox, no long-lasting visual or other effects. And if you've had cowpox, you're very unlikely to get smallpox, even though they're classified as different sorts of viruses, but they're close, we would now say evolutionarily. So Jenner, and in fact, of course, as often happens in the case, it turns out it wasn't only Jenner. It's been done by several other people, but for various reasons, they didn't manage to sort of get their results taken up, whereas Jenner did. Jenner did this famous trial of Thomas Phelps. If you go to the Jenner Museum, you can still see you can see a horn of Blossom, the cow, who was the cow who was thought to have given Sarah, I've forgotten her full name, but Sarah, the girl who had the cowpox, from which Jenner took the pustule and injected it into the boy, who fortunately survived. Now, what happened then was, and I'll stick with England, there are similar stories in various countries we know, but they're very similar to different countries. Parliament got incredibly excited about this because although it's not totally without its risks, this approach, so vaccination, true vaccination, back at the cow, only used in the sense of smallpox, had massively lower dangers than smallpox or even variolation. And it was made compulsory. Acts of Parliament. The Compulsory Vaccination Act, there's a clue in the name. And if you refused to get your child vaccinated, and this happened very quickly, within a few years of Jenner's work, you had a fine of £1. Now, of course, a fine of £1 is unaffordable for most people of the day. And as you may or may not know, if you couldn't pay your fine, rather like now being kept on remand, you were liable to be thrown into a debtor's prison, where, by the way, the fatality rate was pretty similar to smallpox, actually. Seriously, not quite as bad by then, because you're just getting into the Elizabeth Fry, the Quakers, the John Howard penal reforms. So it's beginning to get better, actually, to be fair, but it's still not good. Okay, so the early objections to vaccination. Some people said they didn't work, because, of course, very few things work always. They weren't safe. I repeat my argument, very few things are always safe. And the compulsory introduction violated personal liberties. This is a cartoon I imagine many of you may know. Don't worry, it doesn't matter if you don't, but just out of interest, this is June 1802, Gilray. How many of you have seen this cartoon before? Just wave a hand if you have. Yeah, it's about a third to a half the people in the room. I won't try and do some survey online. The 18th, early 19th century cartoonists were just absolutely wonderful because they would mock, ridicule, satirize everything and everybody. A lot of their prints are only now being displayed because they're thought to be too scatological, too obscene, even for contemporary tastes to publish. Though, of course, they were very widely published at the day. So this is a much more innocuous one, but it's a particularly wonderful one. And you can see the sort of joke is about the fact that you're getting injected with cowpox. I won't bother to turn the lights out in here. I think you can see it well enough. You're getting injected with cowpox, and immediately cows start erupting from you. And if you can just see, which is a rather nice touch in the background at the top, can you see that's the worship of the golden calf? Which at the time when Gilray was writing, nobody would need reminded about the origin of the story. For a slightly different reason, of course, but it connects in quite nicely. Now, current objectives to vaccination. They don't work. They don't always work, as we've just been saying. They aren't safe. They violate personal liberties. There are a few more now, actually. They're made in ways that are considered morally unacceptable. So this ties in with the religion I mentioned earlier. As you may know, not just vaccines for COVID-19, but a lot of vaccines were made without, I think, probably anybody thinking much of it at the time when they were first developed many, many decades ago, from cell lines which were taken from elective aborted human fetuses. So not very surprisingly, when people found out about this, particularly people in the Roman Catholic Church, but also some others, including people with no religious beliefs, were very unkeen on this because it's close to, in some people's mind, either accepting elective abortions, and not everybody does, or it's a rather instrumental use of an entity that might have developed into a human being. And even in COVID-19, as you may know, the Johnson & Johnson vaccine uses cell lines ultimately derived. And the Roman Catholic Church has gone through what I would regard as a number of rather convoluted arguments about whether this is morally acceptable or not. Another standard objection: scientists or companies can't be trusted. Governments can't be trusted. That one tends to draw in more people. And vaccines are part of an international conspiracy. Now, this is a more interesting one because it's very easy to mock this. So, for example, rather a large number of people in the United States, as you may know, genuinely believe, insofar as you can tell somebody genuinely believes something, that a lot of vaccinations are a means for Bill Gates / Microsoft to gather data about people. This genuinely seems to rather bemused Bill Gates, who, as you probably know, set up a rather large charitable foundation with a woman to whom he was married, Bill and Melinda Gates Foundation. But there are sufficient people for whom this has really reduced vaccination rates. And this was the case even before COVID-19. So some of you will know, worldwide, measles cases were beginning to rise, which is why I said early on this has been important vaccine education for about 20 years. I probably should have said it should have been important for about 20 years. Now, on the other hand, there are some conspiracy theories that turn out to be absolutely spot on. So the most one we're absolutely definite about, and I don't know if many of you know this, after 9/11, the CIA in the United States, for obvious reasons, was extremely keen to find out where Osama bin Laden was living. And they knew roughly where he was in Pakistan, but only roughly where. And by coincidence, his sister was in the States, and they got hold of medical samples, her blood, so they could effectively work out what, by genetic profiling, what her DNA was. And therefore they decided if they could get samples of enough people's DNA, they'd be able to find out, for example, if any of his children were around or other close relatives. So the CIA set up in the part of Pakistan where they thought Osama bin Laden was, what they claimed was a hepatitis B vaccination program, the entire aim of which was to collect blood samples for analysis. When this news leaked out, as news usually does, which it did quite quickly, we know of 70 UN and other health people who were killed, mostly working on polio vaccination in Pakistan. Not very surprisingly, a number of international agencies withdrew their staff. The Taliban said that polio vaccinations were a way of the West trying to reduce Muslim fertility, and polio, which was incredibly close to being eradicated as smallpox has been, is gradually increasing again in frequency. So that which at first starts, and I thought initially was a bit of conspiracy theory, is now genuinely accepted in the wide mainstream academic literature as being absolutely true. And then there's this argument they're unnatural, which is a very common argument against lots of new technology. And of course, in one sense, of course, they're unnatural. You know, we didn't evolve to stick extremely sharp objects into people's children, in the case of cowpox, with diseases, quite intentionally. And I mean, I've chatted with people, I don't have children, but I've chatted with people, you know, biology education, others who've talked to me about that. Well, you know, it's quite difficult taking your child to be vaccinated because, you know, half the time they burst into tears. And as you say, you see somebody sticking something very sharp into your young son or daughter. So it's not trivial when you're doing with your children, etc. That's just one of many standard sort of pictures showing people complaining nowadays about vaccines. And of course, COVID-19 has caused a huge increase in objections, not just sadly towards COVID-19, it'd be good if there were more vaccinations for that, but also other things. I didn't give the story which you probably know about rubella vaccination, rubella and MMR, the MMR vaccine, the Andrew Wakefield affair, where he said that it might trigger autism, which is now about the most thoroughly disproved medical hypothesis of the last 20 years, but is believed by large numbers of people to this day who see him as a martyr who's been sacrificed by the medical establishment, etc., etc. These things are very, very, very widespread sometimes in their effects. So just to now say a tiny bit about the different visions one might have for science education. So vision one is probably what most of us were taught in school about vaccines. You know, all that stuff about B cells and T cells, depends how much you did, but certainly about natural and acquired immunity, the fact that, you know, if you get something, you're less likely to get it. But why do we always get colds? Well, there are a lot of different viruses that cause colds, and some of them mutate a lot, but gradually you get fewer colds as the years go by, on average, if your health doesn't drop down too much, etc., etc., etc. So that's vision one. Vision two, which is a sort of citizenship science, would, I think, come with quite a bit of exhortation to get vaccinated, get your children vaccinated, and some sort of comment about for the common good, okay? This is the herd immunity idea, which isn't going to work with COVID for various reasons, like it doesn't work with a common cold, but does work with a lot of diseases where, roughly speaking, the causative agent doesn't change quickly enough. So the memory of the human immune system is really good. So you get the injection, you get vaccinated, immunized, and it'll last decades. So if you get more than 95% of people in an area vaccinated against measles, it can't sustain itself. It dies out. But as you probably know, vaccination rates against measles have not been 95% in the UK now for quite a long time. And in some boroughs are down in the sort of 80s and so on. So we will see more and more people dying, maimed and blind from measles for the next few years. The evolutionary biologist in me thinks eventually, of course, you'll reach some sort of equilibrium because loads of people suddenly decide, actually, once they know of people who died from X, they will do something about it. So. Vision 3, which is one thing I'm thinking about at the moment, would incorporate a lot of vision 1 or 2, but it wouldn't, as it were, just be gung-ho assuming vaccination is a good thing. I repeat, I've been vaccinated against pretty much everything I could be, personal decision, but he wouldn't assume that the people who don't are stupid or selfish. And it would explicitly talk about cases where things have not gone as they should do. It would talk about why, whatever you want to call it, vaccine hesitancy is more common in some communities than others. So as far as I can tell, it looks as though vaccine hesitancy correlates quite well with distrust of the medical profession. So if for whatever reason, due to ethnicity, due to socioeconomic status, due to religion, you're in a community which doesn't have as high a trust of the medical profession as other communities do, you tend to have slightly lower vaccination rates. Also, just more common sense, sort of everyday type thing. I don't know, I mean, again, just those of you in the room, how many of you would describe yourself as early adopters of technologies in general, like, you know, new IT systems or something like that? Yeah, I don't want to stereotype, but I'm not surprised to put your hand up. Good, and him as well. Excellent. So there's 3 people. I'm teasing now, which is the way it's not a very good idea to do, but it's not on a Fisher exact probability test significant by gender yet. One more male will put their hand up. Okay. So most people are not. That's the point. Most people are not early adopters of technology. And yet the way we were all treated with COVID-19 was that we weren't doing our sort of public duty if we didn't immediately adopt the COVID-19 vaccines. And of course, in fact, adoption early on was rather high. I'm slightly less clear, and be grateful if anybody can explain to me why the rate of second and third, so-called booster vaccines, well, the second wasn't even a booster, it was really part of the whole package, are so much lower. I haven't quite got that clear yet in my mind, so I'd be very grateful if anybody can explain this. So I can't remember the percentages in this country, but it's something like 93% of people between the ages of 12 and above had vaccine number 1. And I can't remember, I ought to look it up, but you know, it's 80 something have had number 2, and it's 60 something have had 3. So it goes down quite a bit. I'm not so sure why, whether it's just, you know, people don't think it's quite as dangerous as was thought, you know.
They might have had COVID.
There we are. That's exactly it. So one of the good things about vaccine education you'd want to do with either Vision 1 or Vision 3 is really talk through, well, if you've had COVID, does that mean you don't need to have a vaccination, or does it not mean that? Because it's quite an interesting, COVID, you should still in terms of pure biology, but in some other diseases, you don't need to. And it's quite interesting. It's all to do with, roughly speaking, mutation rates in the causative organism and variation in humans' immune systems and things like that. So it's not a trivial issue. And that doesn't get addressed at the moment in school biology. I didn't study immunology at university, so I don't know whether it gets or now gets or used to get regularly dealt with. Okay, getting towards the end now. Last few points, just thought I'd broaden it out a bit from vaccines. It's not just vaccines. The same sorts of issues are to do with people's understanding of evolution and how we might teach evolution in schools. I'm very happy if there are any comments or questions to do with that. Pretty similar with climate change. The interesting thing about climate change, unlike evolution, though similar to vaccines, is how certainly in the US and the UK, political beliefs are strongly correlated with your views. So gender plays a relatively modest role, which is unusual because usually gender is quite important in lots of attitudes and things. But as I'm sure you both know, as I'm sure as you all know, people who say they're more likely to vote for, whether it's Republican or Conservative parties, are much less likely to accept the standard scientific accounts of COVID-19 or of climate change. It's a greater effect in the US than it is in the UK, but it's quite important. Conspiracy theories in general, I said a bit earlier on about them, but they're growing, of course. Again, there's no very good longitudinal data on how many people used to believe in conspiracy theories and how many people do now, but it seems rather likely that ease of communication and the way in which people build up their understandings of the world are such that conspiracy theories are more important than they used to be. And we just have to think of the poor woman who's gone missing, who may or may not have been found. Is she called Nicola Bulley? In that river. But, you know, thousands of people turning up with conspiracy theories about the police are trying to hide this, or somebody's done this, or whatever, and all the rest, just which did not used to happen when people went missing. You know, you've got people helping with police searches. A couple of weeks later, tragically, sometimes people were either found dead or wonderfully found alive. So it's very different nowadays. And the last academic point I'll make, this is something I've been rabbiting on for a long time because I thought it was helpful with evolution education, is the value of the term worldview. The shorthand of this is that somebody's worldview is basically how they see reality, their construction of truth, if you like. And it's hard to shift. That's the point. So an example I've often given before when doing initial teacher education is that some of you may know this classic question you get taught in schools: where does the mass of a plant come from? I don't think this is a public lecture in this room in terms of a truly representative cross-section of the public. Well, it might be in Oxford, but it's not in London, I can tell you. So if you do ask this question in a public gathering, when I have asked this question, and you give people a choice, does it come from the soil or the atmosphere? You tend to, well, I'll ask you in this room. So hands up if you think most of the mass of a plant comes from the soil. Hands up in this room. Hands up if you think most of it comes from the atmosphere. Good. I'll assume the rest of you either didn't understand the question, because I did rush it, or are not prepared to commit yourself, which is very, very wise. So the standard scientific answer, and give me a bit of time, 40 minutes in school lab, starch test, stuff like that. The standard answer is that the vast majority of the mass of growing plants comes from the atmosphere. It's actually the carbon in carbon dioxide captured in photosynthesis, which, roughly speaking, gets turned with a bit of stuff coming in through the roots from the soil, nitrates, phosphorus, and so on, gets turned into the leaves, the shoots, the roots, and so on. Now, that's a misconception if you thought it came from the soil, most of the mass of the plant. People are not emotively connected to that misconception. I've spent years teaching that in schools, and they all, half of them don't know it beforehand. End of topic test. Slightly more than half of them do know. But if they don't, it's just because my teaching was very good or they weren't very interested. It's not that they're holding on to it. That's very different, isn't it, to somebody trying to prove in 40 minutes that humans are responsible for most global climate change at the moment, or that vaccines are a good thing, or that the Earth came into existence about 4.7, 4.8 billion years ago, and all of us and bananas are descended from a common ancestor. We can widen it out from bananas, as you will know. But so I find the worldviews is quite helpful. And as an educator, it makes me, I feel, less likely to be condescending of people who don't see the world in the way that scientists do. My education is such that from the vast majority of things, I am very close to the standard scientific accounts. And I would certainly like more people to know the standard scientific accounts. But this is the last point I'll make. I don't think it's my role as an educator to tell them that they're wrong or they're stupid or they're selfish if they won't accept the standard scientific account. Thank you. I'll stop there.
Thank you very much, Michael. We might like to